Premium subscriber, you're welcome back to this section, Introduction to Statistics. Today we are looking at for sigma notation, or in general summation, right? Remember that statistics, when it comes to statistics, we play a major role for especially the introductory part. We play a major role when it comes to summation. Summation is a very key thing that we need to understand so far as statistics is what concerned. That's why we're going to take our time to walk you through sigma notation or summation in general, so that you appreciate as you move along when it comes to the classifications of data and those where you're going to deal with a lot of summations a lot. So as we go along with this video, you appreciate how you're going to go through with the various statistical method that involve summation aspects, so that you get to understand everything very well. So let's get onto what. Alright, so you're welcome back once again. So this is what we are saying. Sigma notation. Anytime you hear of sigma notation, we are saying that sigma notation is a method used to write out what long sum in a concise and a precise way. Used to write a long sum in a concise and convenient in a concise and convenient what manner, or in a concise and convenient what way. These are what we mean by what sigma notation. It's a method used to write out long sum in a concise and convenient what way. So where we reduce that long summation into a simplest way that is easily what understood. That's what we mean by what sigma notation. I hope that is clear. So the sigma notation is represented as, so this is a symbol for sigma notation, and I hope all of you have seen this before. Even you can check Casio calculator, you can see this. This is a symbol for sigma notation, which is a Greek word, capital letter what sigma, corresponding to the letter X. So you're saying that this sigma notation is a Greek capital letter that corresponds to this word X, and it refers to the initial letter of the word what sum. Anytime you see of this symbol, we're talking about what sum. So generally, you're going to talk about what summations. Okay, you're going to talk about summation. We try to reduce long summation to a simplest way that makes it convenient and precise for you to understand or appreciate better when it comes to summation. So now, if I have n with my summation symbol, all right, then I have here to be I, and this I is equal to j. All right, then I have in front here ri. This is how, if it gets any summation question in a form of number, it's going to have the representation form. We are saying that this n is called the upper limit. The upper limit for the summation. And this I, right, or the j, which is called the lower limit. The lower limit. Then the r here, we call it a variable. It keeps on changing. I guess what I'm saying. And r changes with respect to the I and the j and the n. So we are saying that the r, right, is a variable key, right, and the n is the upper limit. Then the I is the lower limit, and we are saying that the n is the limit that this r can reach or what end. The n is the limit that r can reach or what end, and then the I here that's the lower limit, is the limit that r will start with. That R will start with. So anytime you have any summation, so for example, if I have something like this, let's say 5 to, let's say here is I, and it's equal to, let's say 1, and let's say here is, how should I start with? Let's say here is what? R1. You can say that if I to start with this summation, this is how it's gonna be. And to work this out, first of all, you know the I should be what? 1. So here, you see where the I is. You're going to have what? R what? 1. So you see, the I is where the R will be starting with, in terms of where the I is, because it plays as what? As a subscript. If we were to be multiplying, then you should have go by that. Then plus, so from the 1 move on to a 2. So R or 2 plus what? R3 plus R4 plus what? So we are saying that the upper limit is the limit where R can what? Reach or end. So we are moving towards R45. So you see that the R started with what? The I. So we are saying the I is the limit, the lower limit with which the R will start. And you see we ended with what? The upper limit where the R will what? Reach or end. And that's why we have gotten here. So that is generally about what? The summation that we're going to talk about. We try to reduce this. So this long summation here that we've seen here, you can reduce it in this form. You can write in this way. So when you're having a presentation of this long sum in this way, you're talking about sigma notation. I hope that is clear. That's what we all mean by this sigma notation approach. So let's take note of that. So you're going to take, generally we're going to take on some practical questions, then we know how to go about, or questions or examples on sigma notation so far how you have done, so that you appreciate what you have done better. All right. So this is example 1. This is example 1. You have to write out what is meant by the following. What is asking you to write a summation, that long word sum, right? Sure, you can also simplify to this further so you get your final answer. I hope that is clear. Right. So here we said earlier on that always the value here is always the upper limit. That R will end. The final value for R will end. Then here is the lower limit that R will start with. Alright? But remember here we are using what? Different what? Letters here, N and then N here. So it means that 5 is the value at which N will what? End. Then here this is the lower limit, is where the N here will start with. I guess what I'm saying. So that's what it's going to be. So here we have N here, so we're going to start with what? So mean N was equal to 1, so we're going to start with what? 1 plus, we said N is a variable, so we keep on changing. So from 1 move on to what? 2, right? Plus, so from 2 you move on to a 3 plus what? 4, then ends with what? 5. You see it started with 1 and ends with 5. So that's how you're going to. So always the value here, or the variable here, is always in between, where it's always in between the lower limit and the upper limit. So you can say that the N here ranges from 1, okay, 1 to 5. So always the N should be between where this N, this N, right, should be, or let me use the R that we're using in general. The R should be in between where the I and the N, which was at the top here from our first word, introductory part, right? So always should be in between. So in this case, it should be in between 1 to 5. So this n here will be in between 1 to 5, and this is how I'm going to. So as first was this, and we're able to reduce it by coming out with a summation where we're able to come out with this sigma notation to reduce this long summation. I hope that is clear. So after all, you can go out to get your final answer. 1 plus 2 is what? 3 plus 3, which is what? 6, right? Plus 4 is 10, so plus 5 is what? 15. Then you are good to go. What about this? The same thing. So here, it's sorry I didn't have the x here is s squared. So here, you're going to start with the r here, which is now x, going to start with what? 3. So it becomes what? 3 squared, right? And it ends with what? 6. Plus, then from there, from 3 move on to what? 4, so 4 squared. Then from 4 move on to 5, so 5 squared. Then ends with 6, it becomes what? 6 squared. I hope you get what I'm saying. So this was the long chain that we were able to reduce it with sigma notation. This was what it was before, and we were able to reduce it to this form. I hope that is clear. Then finally, you can reach here, so you can simplify further by saying 9 squared is what? 3 squared is 9, 4 squared is 16, 5 squared is 25, then 6 squared is what? 36. So when you add them, you get the final answer. I'll leave the final answer for you to work it out. So what will be the final answer? Work it out and put the value there in the comment section. I'll take it, right? Then it comes to the last part of this. We're having 4, which is the upper limit, and the arrow here. So here to the same approach. Just like here having what? A product of 2 terms, but the same thing. So here I'm going to start with what? 1. So where you see r, you start with what? 1. So it means I'm going to have what? This one here, all to the power of what? 1. Okay. Dot is multiplication. Anytime you see dot multiplication, then 1 squared, then plus -1. So here from 1 move on to what? 2, right? Dot 2 squared plus -1 squared, sorry. So from 2, which is the r, from 2 move on to 3, so here will be 3. Then dot what? 3 was squared, then plus -1. So from 3 move on to a 4 dot what? 4 squared. So that's how it should be. So after this, so this was a long chain that we were having, able to break into this simpler formula. We would say that you can have it in this sigma notation form, then we are good to go. So generally, these are how this sigma notation works when it comes to sum. We try to reduce what? Long words, sum in a concise and precise, or in a convenient manner or way. So here to also work it out, the answer and provide for answer. Wherever your calculator, you can solve this and get that. So this is where we bring an end to the first part of summation. So in the second part, you're going to look about the general and the basic formulas that we can use as a short way to reduce this long chain that we used to write here. Okay, assuming here was 100. How will we be able to go by writing all these things? No, it will be a waste of time. So you're going to find a way of reducing it and to simplify it even further as compared to even the sigma notation that we have done in general. So thank you once again. We need to very discuss that. Bye bye.